Hawks, there you go, there we go. Richie, you are now. I will give you a small cut of the profits of what we made, which is 0. All right, friends, let's take a look at our data. There's our beautiful raw data. I want to go ahead and graph it. Let's take a look at it here. I'm going to run one of our stats on this bad boy correctly, though. 1-6. I like what Carolyn said too. She got. She's like, I think it's interesting that we got more 6s and she got none of those. Anybody get no 6s? Interesting. Anybody get no 1s? Anybody get no 2s? Anybody get no 3s? Anybody get no 4s? Anybody get no 5s? Now isn't that interesting? At least one person was in each of those groups, right? At least one. Let's do a real quick analysis again. How many had no 3s? No 3s. That's 1, 2, 3, 4 hands, right? That means the rest of you did have 3s. I asked the question as I was going around, on average, how many fingers should you be holding up? Does anybody have an answer for that yet? 1.5. On average, about 1.5 fingers? On average, you can do that, right? On average, why 1.5? Just out of curiosity.
I don't know, I just seemed
just a gut.
Yeah.
6/10. Not bad shooting.
You know?
Go.
1.5.
1 2/3? That's actually the exact answer, right? Which is damn close to 1.5. How'd you get that 1 2/3 thing? Just out of curiosity.
10 by 6.
He divided 10 by 6. He divided 10 by 6. So you have 10 rolls. Assuming this die is behaving, as Austin said, purely randomly, you would expect the same number of 1s, 2s, 3s, 4s, and 5s, and 6s on average across those 10 rolls, yeah? Isn't that the definition of what a die is? It's a random number generator that generates 1 to 6 numbers equally likely. So we should see on average about 1 2/3 per trial. So theoretically speaking, if I take these numbers and divide them, we have 28, yeah? If we take each of those numbers, I'm going to try something real quick here. If we take each of those numbers and we take L2 divided by 28, those should be pretty close to 1 2/3. And look what we got, friends.
Yeah.
Those are our averages. So Nathan, I see your 1 2/3. You don't want to do it even better. Let me average that column. Just do a little one of our stats on all 3. 1 2/3 is 1.67. 1.66666. That's 1.6. A little too high. A little too high, but hardly too high to be alarmed that something's wrong. So even though Carolyn, I love what you said. I love what you said. I find it weird that we had the most 6s and I didn't get any. And you know what I say? I think it's beautiful. Not because I don't want you to get 6s. I think it's a beautiful happenstance of randomness. That those fluctuations exist, and the only way to kind of view the pattern of the fluctuations is to do something like this, where we all do something and see enough of a sample to actually see what's going on. Fair enough? Good. Now, let's take this to its logical conclusion. I want to graph this first. I want to graph our results real quick with a histogram. Looks about right. A little zoom 9. Now, yeah, I gotta fix it now. Hang on. So I'm gonna set up my window like this: 1, 7, and 1. That way we get 6 bars. So I did a real quick zoom stat, zoom 9, and now I'm gonna fix the window to make it look better. Because TI uses strange scalings and things. So I just changed my 1, 7, 1, my X mins and maxes and my scales to 1, 7, and 1. I could probably change the Y min to 0, I'm guessing. And you know what? What the hell? Let's change that to 60. And we'll change this to... I'll do everything, so I'll go with you guys. Actually, I'll make that 10. That's more logical. So all I'm doing is, you don't ever have to do this, of course. It's just this makes it look more like correct to your eyes. And then press graph. Okay. Do you see our data in that? Hopefully you see it fairly well. Good, good, good. Now it's a little bit messy. What do you think it should be theoretically? What do you think those 6 bars should? Natasha has a vote straight across. You may want to second that. Straight across. Theoretically, the bar should be straight across. Theoretically. No, Laura, why not? Go. Oh, sorry. Let me change the question. Not with this data, of course.
Oh.
If we were to continue this experiment ad nauseum, like in other words, roll them 10 more times each, then roll them 10 more times each, then roll them 100,000 times each, and then we'll collect the data.
I don't think it'll even out.
It won't ever even out perfectly, but it will become more level with more trials. Good. And why is that, friends?
the bigger your sample size, then the less margin of error you have.
Good. On what? Margin of error on what? Keep going, Carolyn. Keep going.
I
Good. Did you hear what she said? The larger your sample size, the lesser your margin of error. I love what you just said. It's 100% correct. On your average what? Go!